Okay, so here comes registers. We will talk about registers in this video. So the register is a basic storage element of computer. Everything that is stored in the computer, it is stored in memory, and the memory consists of lots and lots of registers. Registers are used by the processor for processing. The registers are used by the first level memory, the cache that stores the different commands. A register can only store binary numbers. Just remember this. So in a register, you can only have binary numbers. Why? Because a register is an electronic component. It is a physical container and it is an electronic component. The name of the component is a flip-flop. Flip-flop is a digital circuit made from transistors, and its function is such that it can either store a 0 or a 1. And you want to go in detail, study about flip-flops. But just one thing is that when the flip-flop is having a 0, it retains its value. And when it is having a 1, it retains its value. So we have registered as the number of bits. So 1-bit register will be represented like a box. 2-bit registers, 2 boxes. 4-bit, 4 boxes. 8-bit, 8 boxes, and 16-bit will be 16 boxes. So these boxes will have the values either 1 or 0. So for example, in this 4-bit, if you write 1101, that will represent some value to the computer. This table is very important and you should know this table. So we have denary numbers starting from 0 to 15. Well, they don't really end up 15, but this is just to compare the values with binary and hexadecimal. The binary numbers starting from 0 all the way up to 15. And then the hexadecimal equivalents are like this. So from 0 to 9 are the numbers. And then 10 in hexadecimal is A, 11, 12, 13, 14, 15. So these are the hexadecimal digits. They are equivalent to these binary numbers and these denary numbers. We have already covered how to convert between these three types of numbers. Storage in registers is a mathematical process. So how do you know the largest number that can be stored in a register? Well, it depends on the number of bits. If a register is a 4-bit register, the largest number that can be stored is calculated using these reasoning. So we have 2 to the power number of bits, which here is 4. So 2 to the power 4, and then we minus 1. So 16 minus 1, 15. So 15 is the largest number that can be stored in a 4-bit register. And going back to this table, you can see that 15, and this is a 4-bit register with all ones. So this tells you the reality, the background of that statement, that what is the largest value in a 4-bit register that can be stored. So this largest value equivalent to 15 and hexadecimally equal to F. What is the largest value that can be stored in an 8-bit register? Again, we have 2 to the power 8 minus 1, and it comes out to be 256. Minus 1 gives you 255. Similarly, for the largest number for a 16-bit register, use this reasoning. 2 to the power 16 minus 1, and then that goes to 65,535. This is the largest number that can we have in a 16-bit register. And this is the bits table. This is very useful table. You should remember that how we write these binary and denary numbers. So these are the numbers that we use to convert to and from denary numbers. So if you want to convert a binary number into a denary, we will use this. And if you want to convert a denary into binary, we will use this. And we have already learned the method. So this is just a table that you should remember. And these basic things will help us to do the further processing of numbers in our lessons coming. So just revise all these things and bear them with you. Keep them in your mind whenever we are learning the next ones. Thank you.